In this tutorial I will go through different debugging techniques in LabVIEW. Debugging is important. Debugging is the process of locating and fixing bugs, errors in your computer program, in our case your LabVIEW application or LabVIEW program. And LabVIEW has powerful debugging techniques for debugging your code. And the sooner you learn to use these debugging techniques, the better, because debugging and finding bugs is a very important part of the programming, and make sure to use the debugging tools that are part of the LabVIEW programming environment. Here you see some of the debugging tools or techniques that are part of the LabVIEW programming environment. We will go through these techniques and show some basic examples. First, in LabVIEW you have this run button, and when the run button or run arrow is so-called broken, then it means there are some errors in your program. Here you see the run button. When this is so-called broken, or you cannot run the program, then you can use that as a debugging technique to find what is wrong with your program. Another debugging technique or tool are highlight execution. Then you turn on this light bulb, and then you can use that to see the flow in your program and use it to figure out where the errors are in your program. Another debugging tool are using the probes. Then basically you can just click on any wire or any object and right click and select the probe, and then when you are running the program you will see what kind of results or value that are part of this wire. Another debugging technique is to use pause execution. This is you find it here in the toolbar. So by clicking this pause button or icon, you can pause the execution of the code anywhere in your code, and then you can use these different tools to figure out what's wrong with your application. Finally, you can also use your breakpoints, which is known from other programming languages like Visual Studio, etc. And then basically you just click around in your code where you want to put the breakpoint, and then when you execute your application, the application will stop at that point. So let's start with the run button, or the broken run button or run arrow. So here you see that the run arrow or run button is so-called broken. This means that there are some errors in your program, and if you click on this button you will get this error list, and then depending on how many errors you have in the code you will get a list of errors here, and then you can just start on top, read the information, and you can also double click on it, and then the LabVIEW environment will go directly to the place in the code where the error exists, and then you can use that technique in order to fix the error. So that is one technique, the broken run button, which you find here. Next is highlight execution. Then you turn on this light bulb, and when you turn this on you will after you run your application you will see the flow in the program. You can also select how fast your program should go. Typically you select slow if you want to show all the details. Then you can either select slow, medium, fast, or very fast. So when you turn on this, your execution of your program will go slower than when you not have this highlight execution on. So use this technique to see the flow in the program. You can see values on different variables, on different wires, etc. like this. Next, there's a technique where you can use the probes and the probe watch window. So basically you can click on any object or wires and then select probe, and then you can use the probe watch window. So assuming you have selected different probes in different places in your code, then when you execute your program you can see the values that are flowing through your program. So here I have put a probe here on this wire, and then when the program executes, then you will see the actual value on this wire, like this. Next, you can also use the pause execution, which you find here in the toolbar. So then it means when you click on this, you can pause execution of your program anywhere in your program, and then you can then use these additional tools to check the problem and find errors in your code, like this. Finally, breakpoints. Also here you just right click anywhere in your program and then select breakpoint, and then you will get this small red circle, meaning you have set down a breakpoint in different places of your code, and when running your code the application will stop here, and then you can see the status of the different breakpoints, and this is an important tool to find error in your code and debug your application. So now let's go to LabVIEW and see these different techniques in action. So then let's start with the broken run arrow technique. So this means that when this is the run button is broken, then you have some errors in your code. So let's go to LabVIEW and see how this works in action. So here you see a very basic LabVIEW application. Basically it just I have a file path here, and then I use the read from measurement file to open that file, and then just plot the value here in this waveform graph and show the data here in this arrow. So let's just run this application, and then you see it opens a text file, plots the data inside, and also show the data here in this two-dimensional array. So the first column is the time, which is here, and the second column is the temperature value in degrees Celsius, which are plotted here in the graph. So now, assuming I just delete this one, and then you see the run button is now so-called broken, then I can just click on it, and then I will get this list of error. And when here I can have one or more arrows, so then I here see index array contains unwired or bad terminal, then I can just double click on it, and then you see it goes directly to the place in the code where the error is, and then I see that this is not wired, so then I just wire it and the error are fixed. So this is one basic technique that you should use to find error in your code. So assuming I know how to remove this one, etc., then this is broken, and then I can just double click here and find the error in the code, like this. So use this technique. If I have multiple errors, I remove this one and this one, and you see, or other, still I have only one error, so then, but typically I just fix the error I see until the run button is clickable, and then you can run your program. So this is a very basic debugging technique, but it's very useful when finding bugs in your application. The next debugging technique is highlight execution, and then we turn on this light bulb, and then you can select slow, medium, fast, or very fast. Typically you just want to select slow, because then you can clearly see the flow in your program. So let's go back to the LabVIEW application we have made and see how we can use this highlight execution. So then in our application, let's just turn on this one and also select and then select either slow, medium, fast, or very fast. And I typically want to select slow. So let's now just run the program, and then we'll see what's happening. So run it, and then you see the program goes slower than normal, and then you will see the flow in your program. You will see the values that are flowing through your program. So here you see the file name. Here you will see the size of the array. Here you will see different values that are flowing through the program. So basically Of course, this is a very basic and simple program, but for larger programs, this debugging technique, this highlight execution, is very powerful. So you use it to see the flow that goes through in your program, and then you can easily combine this one with other debugging techniques as well. So the next debugging techniques is to use probe, and basically you just right click any place in the program and then right click and select probe. So let's see how we can use this probe technique to find and debug our application. So now we are back in our basic LabVIEW program. So then basically just right click on different wires and then select probe, and then you will get this probe watch window, and then you see this number here, 3, and then you will find also the same here. So if I do this several places in the code, select probe, and probe here. So now I have 1, 2, 3, 4 different probes, and they are uniquely numbered. So this number 3 is here, number 4 is here. I can also make it a little bit bigger, this probe watch window, like this. And then now when we will run this application, so then you can click on the different probes, and then you will see the actual values on this specific part of the program. So now let's just run the application, and it was of course a basic application. So but now I can go through the different probes here. This number 3, then you see here I find the path to the file. Then you can basically see if there are any errors in the path, spelling mistake in the file name, wrong file extension, etc. Number 4, then I click on this number 4, then this wire gives the following data. So this is basically the entire file with all the data within. Number 5, then I've used this convert from dynamic data to a ordinary two-dimensional array. So then you see the two-dimensional array of data here. So this is column number 1 with time series, and this second column is the actual temperature value. And then I can also open my file, which I have here on my hard drive, and then you'll see that the data in the file is the same as you see here in this two-dimensional array. So this means that the data that I'm capturing here in problem number 5 seems to be correct. Next, problem number 6 is here, and then here I have used the index array to pick out only the column number 1. So this is column 0 and this is column 1, and then you actually see the data here in column number 1. And as you see, also this seems to be correct. So this is a very useful way to see the flow in your application and the different values on the different parts of the code. You can also, of course, combine this probe with turning on this highlight execution, and then you can go through the different probes to see the data while the program is running like this. So this is an excellent tool that you should use a lot when debugging your application. The next debugging technique I want to show you is this pause execution, and then you just turn on this pause icon in order to pause the running application in different parts of your application. So let's go back to our basic application and see this pause execution in action. So now let's just click on this pause icon, and then you see this turns red. This means that pause execution is on. So now I can click on the run button, and then you see application are now stopping at this part of the code. And then I can, in combination with the probe, see the flow in the different parts of the program. So let's just start by removing this one, removing all the probes. I just create the probes once more. different probes around here, like this. And now you see this number 7 file path, and you see the file path here, but the other probes have no values. This means that this part of the code has not been executed yet. And then you can use this tool, step over the sub-VI, or you can use this one, step, so you can basically use these different icons to run to the next part of your application. So now I just click once on this button, step over sub-VI, read from measurement file, then it stops on the next object or part of your program. And now I can see probe number 8. Then since this part here has now been executed, then I can actually see the values here in probe number 8, while the program is now have a pause at this stage in your program. Next, I click on this button once more, step over sub-VI, convert from dynamic data. Now you see it goes to the next part of your program. And then here in probe number 9, which is here, I can see the data flowing here. And it seems to be correct. Next, I can click on this button once more, and then it goes into this one. Finally, I can click once more, and then it has finished execution your program. And then I can find here in probe number 10 also the values here in this part of the program. So then you can use this pause execution in combination with other debugging techniques like this probe, etc. Finally, let's see how this breakpoint debugging technique is working. So basically, you can click anywhere on any wire, right-click, and then select breakpoint and set breakpoint like this. So let's see how this can be used when debugging your application. So now we are back in our application. I can click on any wire. Let's say here, right-click, breakpoint, set breakpoint, and then you see you get this red symbol. And now I already have a probe here, so then you get this symbol. If I click here, breakpoint, set breakpoint, you will also get a symbol like this, assuming 8, which is this probe. I want to just remove this one, and then if I click right click here, select breakpoint, set breakpoint, then you will see this symbol. So typically this is the default symbol for a breakpoint, but if I set a breakpoint where I already have a probe, then you will get this kind of symbol. So then I can set this breakpoint different places in my application. So I have no different breakpoints here, and I can also right click and find this breakpoint manager, which is this one. And then you will get an overview of all the breakpoints that you have in your applications, and when you double click on it, you will find the location like this. You can also either remove that specific breakpoint or disable it. So you can use the breakpoints and the breakpoint manager to get an overview of all the breakpoints. So now let's just run our application, and typically you can also use the breakpoints in combination with the probe and the probe watch window. Now just run application, and then you see it's stopping here after the first breakpoint, and then you can use the probe to watch the values that are flowing, and then you use the same icons here as you used in this pause execution. You can just click here, step over sub-VI, and then you will go to the next breakpoint, and then you can see the flow in your program. Click on step over, and then you will go to the next part of your program, and then you just click through your program in combination with the probes. So you can use that technique to find and locate where the errors are in your application. So now we have learned how to use different debugging techniques in LabVIEW. from the broken run arrow, highlight execution, probes, pause execution, and breakpoints. So make sure to use these debugging techniques, either one of them or the different techniques or tools in combination, because they are powerful tools to find and locate the errors in your application.